Hello everyone, I'm Milin from Waveforms Nepal. Today we are going to make this wall and this table in Grasshopper and render it in V-Ray. I've divided this tutorial into three parts. First, we will make this wall based on Berlin noise using the flexibility plugin. Second, we will make the table using aggregation algorithm using WASP plugin. And finally, we will make some advanced materials in V-Ray like subsurface scattering and displacement elements in V-Ray and make this final result. So let's begin with part 1 of building the wall. Hello everyone, welcome to part 1. We'll make this wall in Grasshopper. So let's start. I will start by making a reference line for my wall. I'll use this line component from direction. I'll give the line a length. Then I will divide this wall using divide curve component. Let's see. I'll make 5 divisions. Then I will move those points using graph mapper, so I could get a wave-like transformation or motion for those points, as you can see in this video. Now I will try some variations for my line to get the wave-like formations. I also use this amplitude component to basically change the value of my vector. I'm trying to figure out perfect value for my wave-like form for these points. I'm trying out different values until I get the right one. Now we are finally getting somewhere. I think values are more proportional. Now I will use the interpolate curve component to make those points into a curve. Now I will extrude the curve to the height I will need for my wall. Since this is in meters, I gave this wall a 3-meter height. I'm doing some grouping work so I can better organize my script. This is very important in Grasshopper, as it might get lost when you're working on a large script. Now I will start making a separate wall as my base wall. Here I'm trying to make a certain type of morphing script where I use two walls, one as the base wall and one as my target wall. The base wall will be flat and planar, while the curve wall, as you can see, is curved to my sine function or the graph mapper. You will see later on why it is important to make a base wall and surface wall. It is basically to use the small component in Grasshopper. Now I will use the 2D populate 2D component to add random points to my wall. This is so that I can make a Voronoi pattern in the wall. I use deconstruct V-Ray component so that I can get the edges of the wall to use as the reason for my populate 2D component. Now I will give some seed value. The number of count, and later I will explore the seed value as well, so that I can try different randomized patterns. Now I will apply the Voronoi component. Now after the Voronoi component, I will use the Weber's Catmull-Clark subdivision to make these curves into a mesh. This is important because later on we'll need to input the mesh into our flexibility plugin, which is the main plugin and its component that I will use to make the wall. Now I will use the flexibility component, and it is called fast noise on a mesh. So it will input some default input components, which I will later on edit and try to explore. Here I will also add weld and average the vertices of a mesh to make my results more smooth. I'm trying to make the mesh more smoother, and here I will I'm trying to explore various patterns, mostly parallel noise patterns, which will be used to make the wave like procedural image through this plugin. Here you can see, I think the result is looking better. I'm trying various patterns, I guess, Although this one is not good, I will try to change various these inputs and see if I can get a better result. So I think now my noise image is almost ready. I think now it is time to map these images onto my curve wall. I use mesh bump to add the bump according to the normal direction. Here you will see I use the output and use the remap and bounce function to make the result more proportionate. I'll map them onto this graph mapper component and use it as weights on a vertex. Now you can see in this Grasshopper preview the shape of the wave-like form is now being projected on the wall. I'll try to edit the bump height, and I think this looks good for my base surface. This looks good. The geometry is looking a bit jagged, so I'll need to smoothen the input mesh a little bit. Now I'm trying to change some input to smoothen my output, so I don't think it is working. So I will now use Weaverbird's component. It's called Catmull-Clark subdivision. I think this is better to make my results more smoother. I think it is better now. I think this is acceptable. Yeah, I think this looks good. Let's do some final tweakings, see if the geometry improves. Now I will group this base surface. Let's name it flexibility, I guess. Now let's say factor waves. That sounds better. Now I will use the surface morph component. Sorry, the smurf, it's called the smurf, and I will use the curved wall and the base wall to morph these factor waves to my wall. Now I'm preparing the geometries to give as an input to the smurf component. I'll name this target surface and maybe base surface. Okay. Something's wrong with my base surface. I hope this will work. Yes. Oh, I gave the wrong geometry. Now it will work. Now I'm aligning the directions using the evaluate surface for the two surfaces. This will be input into the parameter input. But first I will use morph. I meant morph component and morph to U and V directions, and keep it as the base input parameter for my base and as well for my target surfaces. Don't forget to reparameterize surfaces. I think directions are good, so it has morphed. So I think this will be my wall. I'll give it to the preview, and I think this is done. Now I will make some groupings. My script is ready. Let's see. So 2 meshes. Okay, so I've only used 1 mesh using the dispatch component. Okay, I think this looks good. We can still change our design if it's not up, if you don't like it, let's say. I'm trying here to see if it looks better, trying to change the length or maybe change some values in the flexibility component, but I think this looks good. So this is the final result for our walk. This is the end of part 1. So in the next part I will make the table using some aggregation scripts in wasp component. So see you there. Hello everyone, and welcome to part 2, where I will make the table for my design. I'll use some aggregation algorithm from wasp component in Grasshopper. So let's begin. Here first I do some adjustment to my table. I simply start out by making a simple box as the outline for my table inside Rhino, which I will later on use as the references for my boundary for the aggregation algorithm. After the box, outline the box, I make some geometries which will be used as the input for my Wasp plugin. I'll start by making a box and make these reference line, which I will later use as inputs and references for my aggregation points. These are needed to give the points for my aggregation for the Wasp component. I make these lines into the center point for each faces, as you can see in this box. Now I start out by putting some Wasp components as a reference guide for my overall script. It is a good practice inside Grasshopper, if you are building a complex script, to always lay out all the components you are thinking of using, as you can see, so as you don't get lost while scripting, and you will always have a good idea of where you are, where you want to go in terms of your Grasshopper script, as you already have the resulting script you will need, and you will only have to figure out the inputs and the output. This makes the whole process easier. So now I am referencing this geometry as my input geometry for my Wasp core component. I have set up the Wasp basic component as well as Wasp connection from plan. Here I am trying to input the faces and the direction from my cube into the Wasp plug. I use the evaluate surface to get the center point for each faces in this cube. Here you can see in this preview the planes from this cube are looking alright. It looks correct. Now I will add some faces using the list item component into a merge data component, so I can select which faces I want to aggregate. So I will also have to give the name to my outputs and my references, like which part do I want the outline, which will be the reference geometries inside Wasp, as you can see. Now I'm setting up the output component for my Wasp component, sorry. These will be the output geometry from my Wasp component. So you can see the aggregation preview, I guess. Now I have to give this table a reference. Now you can see, I guess it is showing the aggregation inside the table box, but I will still need to do some tweaking in order to get a good result. Now I am referencing the table geometry, which I will use as a solid difference action and give the proper outline shape for my table, as you can see. Now I'm placing the geometry inside the table and aggregating inside the table geometry, but I think the result is not as I expected, so I'm trying to change the position of the cube. I think this will be better. I'm trying to see if I think the square boxes are looking too small, so I'm thinking of scaling these boxes. And maybe change the outline of the table to fit more boxes. Yeah, I think this is okay. This shape looks good. Now I'm making the frames as support for these cubes. I will aggregate them together with the boxes. I'll simply use the outline, use the edge curves of the box. Sorry, the reference line for the box, and use the multiply command and make the support pipes. I will out this pipe into a mesh joint. It is important that you use mesh joint to join all the meshes or sub components into single into a single object, so which can be used as a wasp attribute. Wasp attributes, I think you can understand as basically some extra supporting geometry you can use to aggregate along with your main geometry. In my case, the square cubes are my main geometry, and this this plus shaped pipes are my supporting geometry. You will see later on why I use these two geometry types to make my table. I'm preparing the geometry some more and trying to reaggregate them and see. Let's see how the result will come out. So I think this looks good. Now for the next step in my scripting process, I will use this random reduction component to basically reduce some of these cubes in random. I will also use this percentage component, so reduce the total number of cubes into a certain percent. So I'm trying to see which percent looks good, so I think I'll stick with 74%. Now I will again use the Weaverbird Catnut subdivision to basically make the boxes look more organic, I guess, or make it look more softer, because the pure cubes do not look that interesting. So this is how my cubes look. Now I've added the framing to my cubes as well. They could act as a support for these cubes, theoretically, of course. I'm changing the position of the cube to better align with the supports. You'll see it looks more like the cubes are being held up by those supports. So now I will give them preview my outputs, and we'll see how it looks. So this is how this my table looks, I guess. Let's I guess save it in a view. Now I'll make a tabletop for this table. Of course, we do need a tabletop. So I think this looks good. I think I will save my script. What do you guys think? I think this looks pretty good for this aggregation algorithm. So I think this will be the end of the part 2. And now our geometries, our designs are ready. We will now move on to rendering them in V-Ray. So see you in part 3. Hello everyone. So this is part 3 of our using Grasshopper and Grasshopper plugins and using V-Ray along with our results. So let's start the rendering process. Before I begin, I do some final adjustments to my table. See if I can improve some designs or proposals. I use the fillet edge command to make it look more softer and I guess add some detail to my table. Then I finalize and set up my views. I've made the floors and the ceilings geometry, simple planes for my floor and my ceiling. Yeah, okay, I think This will look okay. Now I think this is okay for my view. Then now I will open V-Ray asset editor and start with a dome light and link an HDR image to my dome light. Remember how you always start with some natural lighting. Either use skylight or dome light. Generally, dome lights give a more realistic result for your natural light. So always start your scene with a dome light. You can give more accurate, realistic lighting values using lumens unit, as they correspond to actual sunlight intensity. I'll test my results. I think it looks okay, but I will change the direction of my dome light. So I think I will need a type of lighting that will highlight the walls and the design for my table. I think this looks much better, really giving out the curves of the wall and also the geometry of the table. Now I will add a rectangular light from the other side. This will balance out the overall lighting for my image. It is looking too bright. I will change the intensity, and always it's a good practice to use radiance, as artificial lights are mostly calculated in radians or wattage, you can say. You can give more realistic control over your light. So I think 20 watts is good. Now I will start with the wall material. I will make a metal paneling material for my wall, as you can see in this image, but my mapping is all wrong. It looks too big. I will apply a box. I start with a spherical mapping, but I think cylindrical mapping will be good for this situation. Cylindrical mapping you can choose in Rhino, as it is good if you have lots of wave-like structures, lots of curvatures. You need to map your texture onto. As you can see, the cylindrical mapping I think will be good for this situation. I'll position my mapping box to my wall, as you can see, and see if it looks okay. I think this is looking better, although I need to scale it a little bit more. There's some errors, so I think I need to scale my mapping a bit more. I used the cylindrical mapping, and let's see. Let's change this a little bit. See if this works. So I guess I think finally we are getting somewhere. We still need to fix our mapping a little bit. I just used a V-Ray scaling from the texture editor inside V-Ray asset editor. As you can see, I'll change the repeat UV values, and I think this looks okay. I think the scaling is good. It moves along the waves, and I think that is how it should look in real life if you were to make such walls in metal paneling. So yeah, I think this looks good. Maybe let's see if we can tweak it a little bit more. see if you can get a better result. Now I will start applying the texture maps, your bump maps, your reflection maps, and finally your displacement map. Here I am applying both the roughness and the bumps. Now to apply the displacement map, I'll call it wall displacement and link the image for my displacement. And I think after this, if we render this, I think it will look good. Yeah, I think it looks okay for now, but I think we can improve it a little more with a bit more lighting, I guess. But it looks good enough for. Here I'm trying to see if I can improve the lighting a bit more, if this will improve my overall scene or not. Now I will add the ceiling and flooring material. I'll use the same material for both. It will be a rough concrete finish, because I am trying to go for this raw industrial look for my scene. So I use this rough concrete material. Similarly, I will add some mapping to it. I'll only use planar mapping as my geometry is plane, my ceiling and my floor, so it will be a lot easier than mapping my wall. But here you can see I'm trying to map my textures on my scaling for my texture. I think this looks good, so I'll save my scene and go to adding bump maps and reflections for this material. You can see the reflection maps. I think I want to keep it a more polished concrete look. So let's see. I'll increase the intensity for the rectangle light as the scene was too dark. So now I think finally the scene looks more balanced in terms of lighting, and the flooring looks good. Now I will make a soft surface scattering material for my cube. So what is a soft surface? It is basically a way in using visualization to make materials that are transparent, semi-transparent, but also has some sort of a thickness, where you can say like sort of a curtain. We can use it for curtains, for plastic materials, even for some natural organic materials like leaves and for even for skin. So I simply use plain white subsurface scattering material inside V-Ray, and I'll now add a metallic finish material from Chaos Cosmos library, and apply that onto my frames. Now after that I will finally apply material to my tabletop. Here I'm trying to see which type of material looks best for my tabletop. I am at this point not sure, so I used the cracked concrete material and see if this looks good. I apply the textures, and I will have to do some mapping as well. I'm trying spear mapping, but I think it doesn't work. So I'm trying various mapping here to see if I can improve the scenes, the curve edges. So far I think it is not working. You see, maybe I can fix this a little more. I think it will give me a acceptable result. Yeah, I think this looks good enough. Let's see how it looks in my render. But first let's apply some textures like your bump maps and your reflection maps. So let's see how this tabletop looks. I think it looks kind of okay, but I'm not so sure about this result. The subsurface scattering looks pretty good here in the cubes. As you can see, this looks like a semi-transparent glass boxes, I guess. Now I will add some vegetation to bring some greenery to my scene, I guess. can always add more greenery to your scene. Here I am adjusting the position of my objects, so if I to get a better result for my scene. I want to go for a well balanced composition. So I'm now trying to change the tabletop material to maybe a glass material and see if it looks good. Maybe it will make the table look more unique. So I import this glass pattern material from Cosmos library, and let's see how it looks in the render. Yeah, I think this looks pretty bad. It looks totally black. I think the reflections are totally off. Let's see if I can fix this, or maybe just scrap that whole idea and just go with the concrete plaster texture. I guess it looks more simpler and good for the overall composition of my scene. Now let's add some decor, I guess. Add a flower glass to my table. And then add some volumetric fog, I think, to keep more overall, I think, give more depth and make my scene more interesting. But I will first have to adjust the range for my volumetric fog. Currently it is just too much, so I will have to scale and change the fog. I'll have to adjust the distance to change the intensity. So I'm increasing the distance. So I think the fog is getting more clearer, but still it is too much. Finally, I think we are getting somewhere, but we'll have to still increase it a bit more. Let's see. Yeah, I guess this will work for now. We can do some more editing later on, but I think this overall is looking good. My materials are ready, my geometry was already ready. Save my view a little bit, and let's walk towards finaling our scene. Here I'm adding a displacement map to my floor and increasing the resolution for my final output. I think this will make my final result even better. Let's see, I think the floor is looking much better, and the final image will come out in pretty high quality. Now I will use the post-production effects in V-Ray frame buffer. You can see V-Ray frame buffer is pretty good for doing some post-processing stuff. As you can see, it has lots of features like frame tone map, white balance, even blurring and sharpening, lens flare effects. These are all pretty good for a post-production, sorry. And sometimes you might even not need a separate software like Photoshop to do your final editing, just like you can see here. I'm just gonna finalize my final output inside V-Ray without using any Photoshop editing. Here I think we are moving towards the final render. I do some final tweaking. There was a mistake in my wall displacement, so I corrected it. And I think this will be pretty good. Add a floor displacement to give some extra detail to my output. I think this will make the floor look much better. Here also I will use make some more editing to my tabletop. See if it will improve my rendering. The bump apps are looking good, I guess. It is not looking up to scale. So I guess I'll just scrap that and finally just use a simple plaster material from V-Ray Cosmos library. I guess it was not looking good enough, so simplicity wins in the end, I guess. So this will be my final render. I will share with you guys how it looks. So this is the final output. I think it came out pretty good. If you want to see this image properly, or if you want to zoom it or whatever, you can do it. I have uploaded this image in my Instagram page, Waveforms Nepal in Instagram, So if you like it, you can check it out. So this is the end of part 3 and the video as well. It was a pretty long video, so it was pretty long for me as well. Hope you guys had a good time watching and maybe learned a few things from this video. If you like my work, please you can consider liking and subscribing to my channel. I want to put out more videos like this in my own time, I guess. So thank you, and goodbye for now.